Hi, welcome to Academy, and in today's video lesson we shall be looking at how to calculate the relative atomic mass. Like I said, we are going to be working on the calculation aspect here. So let's see how we are going to calculate when asked question on relative atomic mass. Now before you start solving, there are some key facts you should have at the back of your mind. One, when asked to find the relative atomic mass, and the relative abundance was given as percentage. Emphasis on what? Percentage. What is the formula to make use of? R.A.M, that is the relative atomic mass, is equal to what? The atomic mass of the first isotope, represented as A1, times the percentage of the first isotope over 100, added to the atomic mass of the second isotope times the percentage of the second isotope over 100. Now if it was three isotope given, you have to continue. Plus what? A3 times what? X3 over what? 100. If it's 4, it will continue that way. But most cases it's usually 2 or 3 isotope given. Now, what if the relative abundance was not given as percentage, but as ratio? What would be the formula you use to get the R.A.M, that is the relative atomic mass? The formula will now be relative atomic mass equals to A. Remember, from atom, A is the one at the top and it represents what? Atomic mass, or you say mass number, but more correctly, atomic mass, times ratio 1, that is the ratio of the first isotope, R1, over RT, that is the total ratio, that is you add up all the ratio to get to RT, times A2, the atomic mass of the second isotope, times R2, that is the ratio of the second isotope, everything over what? That same RT, which is the what? The sum of all the ratios. So this is what you should have at the back of your mind before you start solving any question on relative atomic mass. So about now, I will be giving us the method of solving a practice question, which we are already given here. Let's see how we apply our knowledge of this to solve correctly this question on relative atomic mass. So let's come together and let's do this together. Let's read. They said calculate the relative atomic mass of bromine, or you say bromine, if it occur in how many isotopes? 2. Like they said, 2. Emphasis on what? 2. They said 2 isotopes. Isotopic form. What is the first isotopic form? 79Bro and bromine 81. This is bromine 79 and this is bromine 81. I hope that is clear. These are the 2 isotopes we are giving. Now observe, we are giving the value for A, not Z, showing that for relative atomic mass, you make use of what? The atomic mass, not the Z, that is the proton number. You make use of the atomic mass and not the proton number. You make use of the atomic mass and not the what? The proton number. I hope that is clear. That I'm using A. Observe that too, is it not? Now we have this. They said if the relative abundance is given as 50.69% and 49.31% respectively. Now this is where you have to be very, very careful. You have to be very, very careful here. Because of this word respectively, it means the order in which they gave the isotope is the order it applies to the percentages. First to first, second to second. First before the and, we go with this. While this after the and, we go with what? This. That is the arrangement. So let's see what we now have. Solution. Can we do this together? The answer is what? Yes. Let's get our A1. What is the A1, guys, from this question? Okay, let's do it this way. The first isotope is what? Br79. The second isotope is what? 81Br. Now for each of them, we'll be getting the A1, A2, X1, X2. So let's see if we can get further for bromine 79. Class, what is the A1 here? You have what? 79. Is it not? Because it's the A, which is at the top. Now, what is the percentage X1 of this guy? You observe it. They said respectively, this come first and this come first. So this is the percentage that will go with this. So write 50.69%. I hope that is clear. Then going for the second isotope, which is the second isotope. What is the A2? Is it not 81? 81. Then what is the X2? That is the percentage of this guy. it comes after the and, so it will go with this. So this is 49.31%. So once you have gotten this, you are halfway into your answer. What you now need to write, because you have analyzed all the isotopes, which are just what? 1, 2 isotopes, just 2 isotopes. You now write R.A.M is equals to A1 times X1, okay, let's do it this way, times X1 over 100 plus A2 times X2 over 100. Now we are here. What we simply have to do is to what? Impute all these values into this formula, then we can get our answer. Let's do that together. What is our A1? 79 times what is our X1? Working with the value only. 50.69. We are working with the value over 100. We have analyzed for this first one. Then in between we write plus sign, is it not? Then we go again. What is our A2? 81 times what is our X2? Working with the value only. 49.31. Everything over what? 100. So what you will now have to do with your calculator, you will times this divided by this, get the single answer, put it here, work this, times this to divide it by 100, put the single answer here, then you add it together. So let's see if we can get that done right now, okay? 79 times 50.69, okay? Let's see what we have. Divided by 100. We'll be approximating to the second DP to make it easier for us. Let's do that to second DP. What I have for this, okay? I think I have to do it again. I made some error in the typing. 79 times 50.69, okay? Divided by 100. This is what we have. 40.05. Like I said, approximate to what? The second DP. Plus, we go again for the second one. 81 times 49.31. Is it not? Then you divide by what? 100. We have 39.94. So guys, once you have this, what you simply have to do is what? Add these two together in order for you to get your R.A.M. Is that clear? So let's do the addition together. 40.05 added to 39.94. So when you add these two together, we have, I think make some error, 40.05 added to 39.94. 39.94. We are having exactly 79.99. Now take note, the unit for relative atomic mass is AMU, and that stands for what? Atomic mass unit. So when you are done, you add A.M.U. That is atomic mass unit. So once you are done, you are done. Is that clear? So this is how it is being done for what? Relative atomic mass. If it was given what? Percentage. So we're taking another question now, where I'll be showing you guys how to solve it if by chance you are giving you what? As ratio. So let's get down to the second question now. Alright, this is the second question we were asked to solve, okay? This is the second question we were asked to solve. Now, how do we solve this question? Let's read it together. They said, calculate the relative atomic mass of which element? The answer is what? Copper. If it occurs in two isotopic forms, is it not? They said copper 63 and copper 65. In the ratio, in this case, we are given as what? Ratio. Okay? Ratio what? 7:3 respectively. That is this to this and this to this. Is it not? So that's for that. Let's get started. Solution. Let's see how this is done, guys. Now write out the two isotopes. Copper 6329, copper 6529. Is it not? Now analyze them. What is the A1? What is the A2? What is the R1? Because we are dealing with ratio. And what is the R2? So let's get started. Now A1 for this guy. Mind you, the A is the one at the top. That is the atomic mass. In this case is what? 63. Now, what is the R1 for this? Now, observe that it said respectively. So, first to first. So, the R1 for this guy is what? 7. I hope that is clarified. Then the A2 for this is what? The guy at the top is the atomic mass, 65. While the R2 for what? Copper 65. 65 is what? 3, because it's the second ratio, is it not? And now you have this. You have to know that what? Once you have got to this stage, you have to know the correct formula to use, and that is what? This, the one that has to do with what? Ratio. Relative atomic mass will be equal to A1 times R1 over ROT plus A2 times R2 over what? ROT. Now, how do you get your RO total? These are the two ratios. These are the two ratios. Sum them up. 7 plus 3. ROT is now what? ROT is now what? 10. Is it not? So we can now calculate R.A.M, guys. Yes, we can. So let's do that together. A1 times R01 over ROT plus A2 times R02 over ROT. This is the formula we'll be sticking to during the course of our survey. So just simply impute the values as they appear. This is 63 times what? What is A1? 7 over what is ROT? 10 plus A2. What is A2? 65 times what is RO2? 3 over what is ROT? 10. So what you have to do is times these two together, divide by 10. Times these two together, divide by 10. So we need our calculator here in order for us to be able to effectively do this together. So you have 73, okay? 73 times 7 divided by what? 10. That gives us 44.1. 44.1. So I'll come and write 44.1. Are we together? Plus, let's go for this one. 65 times 3. 65 times 3 divided by 10. This gives us 19.5. So what we have to do, these two values we have, we're going to add them up in order to get our final answer. This will now be equals to, let's get it now, 44.1 plus 19.5. Okay, this will give us our final answer. The answer is 63.6. And like I said, what is the meaning for relative atomic mass? The answer is what? Atomic mass unit. So 63.6 AMU. So this is how it is done, guys. This is how it is done for what? Relative atomic mass. It's very easy. It's not hard. It's very, very easy. So I hope you understand this video lesson on what? Relative atomic mass. Like I said, I'll be giving you guys 1 questions to work on and what? Practice with. Feel free to what? Let me know what you think your answer is in the comment section, and I will gladly reply your answer and let you know if you are correct, and also help you with any correction if need be. So let's get down to the question for the day now. Alright guys, this is the question I want us to try our answer on, and it reads: calculate the relative atomic mass of boron if it occurs in 2 isotopic forms, boron 10 and boron 11, with relative abundance of 4:1 respectively. So this is what we are giving, and this is the question. Do well to try your answer on it using the understanding you derived from today's video class, and feel free to let me know what you think your answer is in the comment section. Thanks for watching. Don't forget to share with your friend. I remain Peters. See you in my next video.